raw version, which is important to know. Then we'll see from there. So IDG ideal gas, IDG ID, IGL ideal gas law or equation. Okay, so PV is equal to nRT, pressure, volume, the amount of the substance N, probably indicating the moles, or the gas constant T, the temperature in Kelvin probably, and PV is equal to RT if we consider the unit form. Yes, uh, if we are studying 1 mole, let's say, so V is equal to RT by P, the reiteration. V is equal to RT by P, so this can be a substitution, and we know that density is equal to mass per unit volume. Mass divided by volume is equal to density, and by V is equal to rho. So, and now we have the form for V. So we put V in this equation 1, substitution A in equation 1. Substitution says that rho is equal to m by RT by rho, which means once again RT by P, which says that rho is equal to mp by RT. Okay, so this is what we have, and what we can do is, if we are supposed to investigate V, then we have to substitute V in the equation of V. Okay, so we get back to the form for V, which says gamma p by rho under the root is equal to gamma p by rho under the root, basically this. And now we have the form for rho, which we can put here, the substitution here B, and this is the form 2, so B into, so V is equal to gamma p by mp gamma p by 1 by mp by RT under the root. So V is equal to, P cancels out, RT goes above, gamma RT by M. So this is a rough version, an approximate form for velocity, which takes into account the universal gas constant, the temperature, the mass, and this quantity gamma, uh, which is actually the factor in Laplace correction. Okay, so we stop here, and we will look into the alterations or iterations later on for this form, because we have a better version. This is approximate, and we have much more accurate versions, but we will look into those later. In discussing the waves, if we take the stationary waves into account and you see, so you see here, um, the stationary waves, and there are different cases for the waves with the string. Okay, stationary waves and string plucked at center. The string plucked at center. Okay, so we have this string and we are plucking it here in the center, and this is node 1 here, and this is node 2, and between the nodes we have the length L. Okay, and when we pluck the string in the middle, if we pluck the string in the middle, what we're basically doing is, excuse me, what we're basically doing is something like this. We have a little wave with a wavelength, and this wavelength only has a crest and does not have a truss here, so this whole length is equal to half of the wavelength. So n1 and 2 is equal to L is equal to lambda by 2. Okay, so in this case lambda is equal to lambda by 2 is equal to L, which means lambda is equal to 2L, and we know that F is equal to V is equal to F lambda. This is from mechanics. V is equal to F lambda. Velocity is equal to frequency into wavelength. This is something we know from basic mechanics, and in this case F would become V by lambda. Okay, and if you put the value of lambda, the frequency will be V by 2L. Okay, notice that we have 2 times the length here. Okay, if for example plucked, if the string is plucked in a quarter, plucked at quarter, this is another case, and what happens in this case is that we have this whole length between 2 nodes and we pluck somewhere here, yes, which is 1/4 of the distance, 1/4, 1/2, 3/4, 4/4, 3/4 and 4/4. Okay, so in this case we have now the situation where we can reach one full wavelength because there is a crest here and there's a trough here, rise and fall. So this is the whole lambda now. In this case is this case 1, and this is case 2, let's say, and here we have this length is equal to lambda. So in this situation n1 and 2 is equal to L is equal to lambda. Yes, length is equal to wavelength. Okay, so and b is equal to f sorry, lambda is equal to L and b is equal to f lambda. So f is equal to v by lambda. So we, for the frequency, we substitute lambda v by L. So now you can see the difference, that we have a form here. Let's call this 1, and now we have another form. Let's call this 2. F is equal to v by L this time. We plug it at a quarter. This is quarter, means L by 4 here, and here we have L by 2. The total is L. The total length is L, and this is equal to lambda, the wavelength in this case. So one thing we can notice is that so if we call it f1 and if we call it f2, so simply f2 is equal to 2 times f1. Yes, and this goes in progression in the case. The second frequency is in this situation 2 times the first frequency.